Integration using trig identities. When integrating, we can use these formulae from the formula book. So integration, so we're looking for something in this column, we're integrating from here to here, or we can use the standard derivatives, but we're going from this side to this side integrating, or we can make use of trig identities, and you need to have memorized all of these, and perhaps you can use an identity first, modify something, and then integrate. Example 1, integrating tan squared. So let's have a look at the standard integrals, and there is no tan squared on this side, so we can look at the derivatives, but on this side there is no tan squared. So then we look at the identities, there is no tan squared here, but there is a tan squared in this identity here. So we can rearrange this, so tan squared is equal to secant squared minus 1. So instead of integrating tan squared, we're going to integrate secant squared x minus 1. So secant squared x is in the formula book, so we can integrate secant squared to get tan. So secant squared gives tan x, integrating minus 1 gives x, plus a constant of integration. Example 2, integrating sine squared x. So in the standard integrals, it's not in here. Derivatives, it's not on this side. So then we look at the identities, and we're looking for sine squared. So we can use this, because we know how to integrate cos. Okay, so I've put the half on the outside, not necessary, but it makes things a little bit easier. And then now we have to integrate 1 minus cos 2x. So integrating the 1 gives x. Integrating minus cos, so we're here, minus cos will give minus sine, so minus sine, same angle, 2x. Then we divide by the coefficient of x, which is 2. We're dividing by 2. So this all goes in brackets. We still need to multiply by a half, and there's a constant to add on. Simplified, we get this. Example 3. We can use a double angle formula for this one. So we know that sine 2a is 2 sine a cos a. So if we modify the angles, because what we have here is this part is actually here. So a is 3x, so 2a will be 6x, like this. And then we need to divide both sides by 2, because there isn't a 2 as a coefficient there, so that's gone. So now we can write sine 3x cos 3x as a half sine 6x, which we can easily integrate. We couldn't integrate this directly, but with the use of this identity, we now have a half sine 6x, which we can integrate. Okay, so if we integrate sine, that's positive sine, so we're here, we get minus cos. Same angle, 6x, we divide by the coefficient of x, which is 6. We were multiplying by a half, so we're multiplying by a half. There's a constant of integration to add on, and simplified we have this. Example 4, integrating secant x plus tan x squared. Expand the brackets. Now to integrate tan squared, we need to use an identity. This one here. So tan squared we need to replace with secant squared minus 1, like this. And then take like terms and simplify. There's a secant squared term here, there's another one here. So now we have this, 2 secant squared. So integrating secant squared will give tan, and then there's a 2 there, we multiply by 2. We divide by the coefficient of x for the angle there, so it's just divide by 1, which is not doing anything here. And that was just using this. Secant squared gives tan. Integrating minus 1 gives minus x. Integrating secant tan. So the standard integrals, there is no secant tan on this side. in the derivatives we do have a secant tan here, so integrating secant tan will give us secant. So if we differentiate secant x, we get this result here. So integrating is going from the right hand side to the left, so we're going to end up with secant x. We divide by the coefficient of the angle, which is 1, which is not doing anything here. We were multiplying by 2, there it is, we're multiplying by 2. And then fully simplified, plus the constant of integration. So for problem solving, we have the standard integrals in the formula book. We have the standard derivatives, which can be used in reverse order. And then there are a number of identities which need to be memorized. So some of these come from the, like these ones here, the double angle identities, come from the addition angle identities. And then you've got these here, which are the Pythagorean identities. For practice, try these questions.